There is a principle buried inside every procurement decision the Israeli Air Force ever made. It was never stated officially, it does not appear in any doctrine document, but it runs through 7 decades of acquisitions like a thread. The principle is this: the aircraft does not matter, the problem matters. Every jet in this list was purchased to solve something specific: a gap in capability, a threat that had emerged, a mission that nothing in the current inventory could execute. When the problem changed, the aircraft changed. When no one would sell Israel what it needed, Israel built it. And when it built something good enough, it modified it past the point the original designers would have recognized. 28 types, 76 years. A combat record no other air force on earth has replicated. This is not a history of what Israel flew, it is an accounting of what Israel needed and what it used to get it done. Chapter 1. The speed gap and how France closed it. The first jet in Israeli service was not acquired because it was the best available. It was acquired because it was available at all. The Gloucester Meteor arrived in 1953, an 11-aircraft delivery of single-seat F, 8 variants plus 2T. 7 trainers, purchased from Britain at a moment when most Arab air forces were still operating propeller-driven aircraft. The Meteor's top speed sat around 965 kilometers per hour, and by Western standards, the aircraft was already aging. That assessment missed the point entirely. The relevant benchmark was not what was flying over Europe, it was what was flying across the border. Against that standard, the Meteor gave Israel a generational advantage. It moved quickly to exploit. Frontline service was short. Within 2 years, a more significant supply line had opened, and the British aircraft was relegated to secondary roles. What it proved in the time it had was something more durable than any performance figure. That Israeli mechanics could keep jets flying, Israeli pilots could fly them to the edge of the envelope, and Israeli infrastructure could support a jet-capable air force faster than anyone had expected. That supply line came from France, and it opened for reasons that had nothing to do with Israel specifically. Paris was fighting a counterinsurgency in Algeria that Egyptian President Nasser was actively funding and arming. Israel faced Nasser across the Sinai. Shared enemies produce practical arrangements. The first aircraft to arrive under that arrangement was the Dassault Aragon, 75 of them, entering service in 1955 and designated locally as the Tsukit. The Aragon was France's first operational jet fighter, straight-winged with a top speed of roughly 940 kilometers per hour. At Suez, in October and November 1956, our Aragons flew ground attack missions against Egyptian armoured columns in the desert. They also encountered Egyptian MiG-15S in the air, and they claimed kills. For an aircraft that was already dated by mid-1950s standards, that record reflects something more interesting than the machine's capabilities. It reflects what the pilots were doing with it. The same airframe, in a lightly modified training configuration called the Tsukit, kept flying in Israel until 2003. The same jet that fought at Suez in 1956 was still teaching Israeli pilots to handle jet aircraft nearly half a century later. Almost nothing else in aviation history has that kind of longevity. That straight wing was the Aragon's ceiling. Once Egypt received MiG-15S in meaningful numbers, the performance gap began closing in the wrong direction. The answer was the Dassault Mr. Ivor, 60 aircraft delivered in 1956, swept wing and capable of exceeding the speed of sound in a dive. During the Sinai campaign that same year, Mr. S engaged Egyptian MiG-15S and de Havilland Vampires in engagements that went decisively Israel's way. The swept wing changed the performance envelope enough to matter, and it pointed towards something that mattered even more. The problem after the Mystère was level flight supersonic performance. Transonic in a dive was no longer sufficient against what Soviet industry was putting into Arab hands. The Dassault Super Mystère B-2 arrived in 1958 36 aircraft, the first Western European production fighter capable of sustained supersonic flight in level conditions, reaching Mach 1.1 at altitude. It carried 230mm cannon, rockets, and bombs on underwing pylons, and it flew through 3 major wars before retirement in 1976. Pilots who flew it described the transition from the Mystère as immediately apparent in the handling, particularly in the vertical. What it represented in the catalogue was a bridge, the last French jet built on propeller-era design logic before the architecture changed entirely. Chapter 2. The Shahak, 6 days, and the embargo that built an industry. The Dassault Mirage, the ICJ, arrived in 1962. Israel received 72 aircraft, designated the Shahak, delta wing, single engine, Mach 2.2 at altitude, a climb rate that made everything else in the region look slow. The aircraft could accelerate vertically from a standing start at low altitude and reach combat ceiling faster than any opponent it was likely to face. In the hands of Israeli pilots who had been training specifically for offensive air engagement since the mid-1950s, the Shahak became something its French designers had not entirely anticipated: the primary instrument of regional air dominance. On the 5th of June, 1967, that dominance was demonstrated in the most direct way possible. The Six-Day War opened with Israeli preemptive strikes on Arab airfields. Within 3 hours, more than 300 Arab aircraft had been destroyed, the vast majority on the ground, caught before they could reach altitude. What followed in the air over the next 6 days was systematic. Egyptian, Syrian, and Jordanian air arms were dismantled engagement by engagement. By the end of the war, over 400 enemy aircraft had been destroyed. The Shahak flew at the center of every major air combat. One pilot, Jura Epstein, flying the Shahak across multiple conflicts, accumulated 17 confirmed aerial victories, the highest total of any jet pilot in the history of combat aviation. The aircraft itself was decisive, but the campaign also exposed something the Israeli Air Force understood immediately. A doctrine built on air superiority depended on maintaining the aircraft that delivered it. And that aircraft now came with a political risk attached. Charles de Gaulle imposed an arms embargo on Israel in 1967. 50 Mirage 5 aircraft that Israel had ordered, designed to Israeli specifications and already paid for in full, were frozen in French hangars. They were eventually sold to other countries. Israel received nothing. The response to that embargo would reshape Israeli aviation for the next 3 decades. Israeli intelligence obtained detailed technical documentation on the Mirage design through contacts in Switzerland. Using that material alongside domestic engineering resources, Israel Aerospace Industries built an unlicensed copy. The IAI Nesher first flew in 1971. 61 were produced. During the Yom Kippur War in October 1973, Nesher pilots claimed over 100 aerial victories against Egyptian and Syrian aircraft. Not one Nesher was lost in air-to-air combat. The aircraft that France refused to deliver had been rebuilt from documentation, improved in several respects, and flown into the most intense air combat the Middle East had seen since 1967. The Nesher used a French engine. The next step used an American one. The IAI F-35I first flight in 1973 replaced the Snecma Atar with the General Electric J-79, the same power plant installed in the F-4 Phantom, producing 8,120 kilograms of thrust. The Kafirsi 2 variant, introduced in 1976, went further. It became the first production combat aircraft in the world to fly with canard foreplanes as standard equipment, small delta surfaces positioned ahead of the main wing that transformed low-speed handling and tightened the turn radius significantly. Engineers had identified the instability at low speeds as the Mirage Delta's primary tactical limitation. The canards fixed it. Total Kfir production reached 212 aircraft across all variants. The last ones flew in Israeli service until 1996. The embargo that was intended to ground the Israeli Air Force had instead forced the creation of a domestic aerospace industry capable of designing and manufacturing frontline combat aircraft independently. That industry would later install its systems in every American aircraft Israel ever operated. Chapter 3. Skyhawks, Phantoms, and the missile that changed everything. In 1966, the United States began supplying combat aircraft directly to Israel for the first time. The political calculation in Washington had shifted, and the opening delivery reflected both the strategic alignment and the specific tactical gap Israel needed closed. The Douglas A-4 Skyhawk was what arrived first. Over the following years, Israel acquired more than 300 of them across multiple variants, designating the aircraft the Ayit. The Skyhawk was small, single-engine, with a maximum payload of around 3,700 kilograms, and a design philosophy built around simplicity and maintainability. It was not glamorous. It was available, reliable, and capable of flying a very high number of sorties with a very small ground crew. During the War of Attrition against Egypt from 1967 to 1970, those qualities mattered more than raw performance figures. Thousands of attack sorties flown against fortified positions along the Suez Canal, day after day, at low altitude, at risk from ground fire throughout. The Skyhawk absorbed that operational tempo better than anything else in the inventory. October 1973 changed the calculation. Egypt and Syria launched a coordinated surprise attack on Yom Kippur, and both armies had equipped their ground forces with Soviet SA-6 gainful surface-to-air missile systems. The SA-6 was radar-guided, mobile, and operating on frequencies. Israeli electronic warfare systems had not been configured to jam. The results were immediate and severe. In 18 days of fighting, the Israeli Air Force lost approximately 50 Skyhawks. The losses came almost entirely from ground-based missiles, not from enemy fighters. It was the heaviest single conflict loss in Israeli Air Force history, and it forced a fundamental reassessment of how strike aircraft needed to approach defended targets. Suppression of enemy air defenses went from a supporting mission to the primary tactical problem. The aircraft that solved that problem had already been in service since 1969. The McDonnell Douglas F-4 Phantom II entered Israeli service as the Kurnas, meaning sledgehammer, 204 aircraft total, twin engine, 2 crew, Mach 2.2, a combat radius exceeding 700 kilometers, and a payload capacity of 8,400 kilograms. Where the Skyhawk was a light attack platform built for simplicity, the Phantom was a long-arm weapon. During the War of Attrition, Phantom crews flew deep penetration raids into Egypt, striking radar stations and air defense infrastructure around Cairo on missions that lasted more than 2 hours round trip. The aircraft reached targets that nothing else in the inventory could reach, at a speed and altitude combination that made interception difficult. In the Yom Kippur War, pilot Aviam Seller claimed 5 Syrian aircraft in a single day of combat. The Phantom flew as the backbone of Israeli offensive air power through the entire decade of the 1970s. Its reconnaissance variant, the RF-4E, carried Israeli integrated optical and electronic intelligence systems and flew collection missions across the entire region through the 1980s, providing targeting data that shaped operations years after the original platform would otherwise have been retired. The Phantom proved one thing above everything else: range multiplied by payload, combined with Israeli avionics integration, produced a capability that no export customer had purchased and no adversary had fully anticipated. Chapter 4. The Eagles arrive, and a record nobody has matched since. In 1976, the first McDonnell Douglas F-15 Eagles landed in Israel. The variant was the F-15A and B, designated the BAZ, thrust-to-weight ratio above 1. The aircraft could accelerate vertically from a standing start. Its APG-63 radar tracked multiple targets simultaneously at ranges beyond 100 kilometers. Israeli engineers began modifying it immediately. Al-Isra electronic warfare systems replaced American equivalents. ELTA radar modifications were integrated. Israeli communications and data link architecture was layered into the airframe. The American aircraft that arrived in Israel in 1976 was not quite the same aircraft that left the factory in St. Louis. On the 27th of June 1979, pilots of the 133rd Squadron intercepted a formation of Syrian MiG-21S over Lebanon and destroyed 5 of them without loss. It was the first aerial victory for the F-15 Eagle anywhere in the world. Israel flew the type into its first combat before any other operator. The record that followed across multiple conflicts was 58 confirmed aerial victories in air-to-air engagements with 0 F-15 losses in air-to-air combat. No other aircraft type in the history of modern aviation carries a comparable number. The F-15 D-BASM Shupar integrated deeper Israeli avionics packages as they became available. And the aircraft continued accumulating that record through conflicts in Lebanon and Syria across the 1980s, 1990s, and 2000s. In 1998, a variant arrived that represented something qualitatively different. The F-15I Ram Thunder 25 aircraft built specifically for Israel. No other export customer received the same configuration. Payload capacity over 11 tons. Combat radius with aerial refueling exceeding 4,400 kilometers. Every sensor system Israeli sourced, every weapon integration domestic. The Ram was not a regional air superiority platform. It was a strategic strike aircraft with the range to reach targets in Iran and return. The transition from the Baz to the Ram represented the moment Israeli air power stopped being a regional tool and became something with genuinely strategic reach. The problem being solved was no longer air dominance over Lebanon or the Sinai. It was the ability to hit anything, anywhere, in a theatre extending from the Mediterranean to the Persian Gulf. Chapter 5. The F-16 and the missions nobody thought were possible. The General Dynamics F-16 Fighting Falcon entered Israeli service in 1980 as the Netz Sparrow Hawk 75 initial aircraft. It was lighter than the F-15, single engine, with a thrust-to-weight ratio and turn performance that made it the best close-in fighter of its generation. Israel integrated its own avionics from the first delivery and began planning missions around the aircraft's capabilities almost immediately. On the 7th of June 1981, 8 F-16s took off on a mission that had no precedent in the history of air power. The target was the Ozark nuclear reactor outside Baghdad. The pilots flew at low altitude to avoid radar detection, crossed hundreds of kilometers of hostile airspace without being intercepted, and put their weapons on target in under 2 minutes. Each aircraft carried 2 Mark 84 bombs weighing 900 kilograms each. The reactor was destroyed. No Israeli aircraft were lost. It was the first military destruction of a nuclear reactor in history, executed by a force that had been operating the F-16 for less than a year. A year later, the scale of what the F-16 made possible became clearer still. On June 9th and 10th, 1982, F-15S and F-16S combined over the Bekaa Valley in Lebanon for air engagements that became the largest since Korea. 82 Syrian aircraft were destroyed in 2 days. Israel lost no aircraft in air-to-air combat. It remains one of the most asymmetric air battles in modern military history, a demonstration that Israeli avionics integration and pilot training had produced a qualitative advantage large enough to render numerical parity irrelevant. The F-16 continued evolving in Israeli service across 4 distinct variants. The F-16C and D, Block 40, designated the Barak, arrived in 1988, 75 aircraft. The integration of the Lantern targeting system gave Israel the ability to conduct precision strikes in darkness and all-weather conditions for the first time. Night was no longer a constraint. In September 2007, Barak aircraft executed Operation Orchard, destroying a nuclear facility under construction near Deir ez-Zor in Syria. Israel acknowledged the strike officially only in 2018. Between the Barak deliveries and the next major variant, Israel tried something else entirely. The IAI Lavi was a domestic single-engine Delta Canard fighter developed through the 1980s, incorporating Canard technology. The Kafir program had pioneered a fully Israeli avionics suite. More than $1.5 billion went into development, including significant American contributions. The prototype flew on the 31st of December 1986. Thrust-to-weight ratio of 1.08, payload of 7,300 kilograms, performance figures that compared favorably to anything in its class. The United States government pressured Israel to cancel it, concerned about competition with the F-16 on global export markets. In August 1987, the Israeli cabinet voted to terminate the program by a margin of 12 votes to 11. 2 prototypes, the technologies developed for the Lavi, particularly its avionics architecture and aerodynamic research, were subsequently transferred to China. They contributed materially to the development of the Chengdu J-10. That transfer remained politically contested for years afterward. The 4th F-16 variant was the F-16I Sufa Storm, 102 aircraft delivered from 2004 onward, based on the F-16D Block 52. The Sufa carries conformal fuel tanks integrated directly into the fuselage, extending range without the drag penalty of external tanks. Every avionics system is Israeli. All weapons integration is domestic. It is today the most numerous combat aircraft in the Israeli Air Force inventory, and it represents the final expression of a design philosophy that began with the first Nets delivery in 1980. Take an American airframe, strip out what does not fit Israeli requirements, and install systems that reflect 4 decades of accumulated operational experience. Chapter 6. The Invisible Fleet. In December 2016, the first 2 F-35I aircraft landed at Nevatim Air Base, designated the Adir Mighty. The F-35I is not a standard F-35A. The designation carries a specific meaning. Israel negotiated the right to integrate its own software, sensors, and weapon systems into the airframe, producing a hybrid of American low observable technology and Israeli electronic warfare expertise accumulated over 5 decades of continuous operational experience. The result is an aircraft that uses an American fuselage and stealth coating around an Israeli brain. Unit cost sits at approximately $100 million per aircraft, partially financed through the annual American military assistance package guaranteed under the 2016 Memorandum of Understanding. On the 22nd of May 2018, the Israeli Air Force declared the Adir fully operational. 2 days later, on May 24th, Israel revealed that it had already used the F-35I in combat on 2 separate occasions, making it the first country in the world to conduct operational missions with the type. The targets were not disclosed, the locations were not disclosed. Only the fact that it had happened was confirmed. A 5th-generation stealth aircraft, less than 2 years from first delivery, already flying classified combat strikes in a live operational environment. The Adir's classified strike record since that announcement has not been made public. Israel has ordered 75 aircraft across 3 procurement lots, with a stated intent to field more than 100 5th-generation stealth aircraft by 2030, replacing all older F-16 variants currently in service. From the Gloucester Meteor in 1953, acquired because it was the only jet available and relative advantage was what mattered, to the Adir in 2016, acquired with custom software integration and already operational before the ink on the delivery receipts was dry, the Israeli Air Force followed a single organizing logic through every procurement it ever made. The aircraft was never the point. The problem was the point. The aircraft was what you used to solve it. That logic produced the first aerial victories for the F-15 Eagle. It produced the first military destruction of a nuclear reactor from the air. It produced the first operational combat missions flown by a 5th-generation stealth aircraft. And it produced, somewhere in the unclassified gap between what is known and what has only been confirmed as having happened, a record of operational use that no other air force on Earth has anything close to matching. The problems have not stopped. Given what is currently operating out of Nevatim, neither has the principle.